Another important problem. Okay, most important problem. If they ask AC, how to solve this? Use nodal method. Here they had mentioned you have to use nodal method, means nodal analysis to find the value of Vx. Vx is unknown variable, unknown value. You have to find out Vx such that current through 2 plus 3j. Current through this one is 0. So the three meshes are there, I1, this is I2, and this is I3. And even that current through this is 0. Current through this one is 0 means nothing but I2 is equal to 0. So that is nothing but current through 2 plus 3 is nothing but I2 is equal to 0. So write nodal equation. So in order to write using nodal analysis, no, so there are two nodes here. And this is reference node. So apply KCL at node 1. So assume all the currents are going away from the node. So V1 minus, so you can write here one more step I will write here, V1 minus 30 angle 0 by 5, potential difference V1 minus 30 by 5, V1 minus 0 by J5, V1 minus V2 by 2 plus 3J. This is nothing but right side current. That given 2 plus 3J current through that one is 0. This is nothing but I2. I2 is 0 they are given. So we left with V1 is equal to 1 by 5 plus 1 by J5 is equal to 5 6 are 30. So 5 6 are 36 angle 0. Now if you calculate this, we'll get V1 value as 21.21. So let me do that. We get it should be in complex degree mode. 0 divided by 5 will give you 6 angle 0. Angle 0 you can write, or without that also you can write. You can write complex. Then third option we'll get that 6 angle 0. That angle is not showing since it is 0. After that, this 6 angle 0 divided by, okay, 5 minus 5 to this is 0.5. 1 by 5 is 0.2. 1 by J5 is 1 by J5 is 1 divided by J5 is again 0.2 J, 0.2 J minus 0.2 J. So that you can do. Now again we have to find out 6 angle 0 divided by 0.2 minus 0.2 J. 0.2 minus 0.2 J will give you 15 plus 59, which is in a polar. Third option 21.21 angle 45. This is V1 value. Similarly, apply KCL at node 2. If you apply KCL at node 2, this is the node. Again, assume all the currents are going away. One current left side, one current right side, one downwards. Left side is again I2 is equal to 0. So no need to write V2 minus V1 by 2 plus 3J is 0 only. V2 minus 0 by 6. V2 minus 0 by 6. 2 by 0 by 6. Then V2 minus Vx by 4 is equal to 0. We will get Vx value. So this I2 is equal to 0. Current to 2 plus 3 is given now. So V2 by 4. V2 minus Vx now. That Vx by 4, if you bring it to right side, you will get positive Vx by 4. This minus this Vx by 4, if you bring it to right side, it becomes plus Vx by 4 in the right side. Then 1 by 4 is 0.25, 1 by 6 is 0.66, 166, V2 is equal to this much. So this is, if I add these two, 0.416 V2 is equal to this much. So Vx is equal to 0.416 V2 divided by 0.25. So finally we have to find Vx now. That's right. And one more important, since current through 2 plus through J. This is very, very important. Since current flowing through 2 plus 3J is 0, potential difference between node 1 and node 2 is 0. That means V1 minus V2 should be 0. In order to I2 is equal to 0, V1 minus V2 should be 0. So this is equal to V1 is equal to V2. So we already calculated V1. So V2 is also this much. So just multiply, substitute the value of V2 which is same as V1, multiply with 1.66, that will give you this. So this is so many times asked in the exam. Answer also I can remember 35.35 only. You should get in the exam also. This is most repeated problem. This is 1.664 into 21.21 angle 45. You keep the answer both in rectangular as well as in polar coordinate. 35.29 angle 49. So this is the answer. Then read this also if you want. Last problem. For the network shown in the determine the node voltage using nodal method. So this is a AC problem. So there are two nodes, node 1 and node 2. It's a reference node. So while writing how to write KCL is you have to assume all the currents going away from the node. While applying KCL for one, consider the currents are going away. While applying KCL for this, consider this. So left side current V1 minus this current V1 minus right side current V1 minus V2 by 4, V1 minus 0 by J2, V1 minus 50. Here actually it is right side. It is, you know how it is right side means they converted this one into current source. It is a voltage source now. You can write here one more current as 5 angle 0 by 5 and same 5 ohm you have to connect in series. Otherwise what you can do is you can write three currents as V1 minus 5 angle 0 by 5. Okay, then V1 by J2 and V1 minus V2 by 4 is equal to 0. This 5 angle 0, if you bring it right side, it becomes 5 angle 0 divided by 5. So this is important. So here why they are current here it is, they converted this one into current source. After that you can apply current going to the node is current leaving from the node. Okay, this current they consider as current going to the node and three impedance are connected now. You can write they are written like this. So you have to write like this. So you are going to get V1 if you take common 1 by 4, 1 by J2, 1 by 5, common 2 1 and okay, common 2. These are the impedance connected to the node 1. 1 by 5, 1 by J2 and 1 by 4. Common 2 between a node 1 and node between a node and 2, 4 is there, so that you have to write minus. So impedance connected between node and node 2 is V2 and 1 by 4 is equal to 5 by 5 is 1. This 5 angle 0 is nothing but 5. 5 by 5 is 1. You can write 1 angle 0 or simply 1. This is equation number 1. And this if you add 1 by 4 plus 1 by 5 will get 0.45. 1 by 2 is minus 1 by 2 is 0.5. 1 by j is nothing but minus j. We'll get this much. The equation number 1. Similarly, apply KCL for node. apply KCL for node 2, I will write here. First equation is left side is V2 by V1. Again, you have to consider all the currents going away from V2 by V1 by 4. Down current is V2 by minus J2 because it is a capacitance. Right side current is V2 minus, this is V2 minus 50 angle, sorry, 5 angle 90. 5 angle 90. 5 angle 90 by 2 is equal to 0. That if you apply, you'll get V2 minus, now that if you bring it to right side, 5 angle 90 by 2, it will become right side means it becomes positive. So here it is there. Okay. V2 minus V1 by 4, V2 by this. This is V2 minus 5 angle 90 by 2. So this, if you bring it to right side, it become like this. So again, this is nothing but sum of the impedance connected to the node 2 is positive. Between node 1 and node 2, we have 1 by 4. That is impedance. That here should be negative. Between 2 and the impedance connected to the node 2 is 1 by 4, 1 by 2, 1 by 2j. That is positive value. And simplify, you'll get this. And again, if simplify this, you'll get this much. Two equations you are going to get. This one. The original delta is this. You have to solve using Cramer's rule only. To solve using Cramer's rule only. Original delta is this. You can write in form of matrix. Unknown variables are V1 and V2. So you have to solve using Cramer's rule. V1 is delta 1 by delta, where delta 1 is first column is replaced by voltage value. Voltage value is 2.2j and 1 and 2.5j. 1 and 2.5j, right? First column of this original delta is replaced by right side value. So find determinant this into this minus product of these two. I'll get this much. So delta 1 by delta. For delta also, this also original delta value is this. So product of these two minus product of these two. You get this much. After that, delta 2 is second column is replaced by right side value. So here you can write one more matrix better. Here I will only write here. I am writing equation number 1 and 2 in the form of matrix. And 75.5 J. From equation number 1, 0.45 minus 0.5 J minus 2.5. So this is original delta. This is unknown variable. This is right side value. To find V1, first column is replaced by right side value. Then you have to find determinant of those two. Delta 1 is determinant of delta 1 by original delta. Original delta is original matrix delta. You have to find matrix determinant of this. Delta 1 is this column is replaced by this. Delta 2 is second column is replaced by this. In all the cases, you have to find determinant values. You have to do it using complex mode, and it will take more time. So you should be very careful. After that, V1 is delta 1 by delta. So using calculator mode, go to divide box by box and you enter these values. You'll get this answer. Similarly, delta 2 is V2 is delta 2 by delta. You'll get this answer. So normally they'll ask, but if another problem is, if choice is given, try to do DC network only. If both are AC, then only you try to attempt. Thank you.